now we are going to have our first talk, by Professor Yong. He has been in the Chinese Academy of Sciences as an executive deputy director. He's also in the key lab of the Big Data Mining and Knowledge Management, again on the Chinese Academy of Sciences. He still has his chair in Information Science and Technology at the University of Nebraska, in the USA. So he goes back from China and USA back and forth. And he has published several books, 22 books and over 200 papers. He's also the editor-in-chief of the International Journal of Information Technology and Decision Making. He's the editor-in-chief of the Annals of Data Sciences, and he's member of some editorial board of several also journals. He received several awards, like the George Cantor Award on multi-criteria decision making, his major, field. The Funden Prize of Distinguished Contribution in Management, the Funden Premium Fund of Management in China, Outstanding Young Scientist Award, National Natural Science Foundation of Science, and he's also a speaker of Distinguished Digital Program from the IEEE Computer Society. He also consulted in several companies, and we could go on and on, but you can also read it here. So I let him talk about the big data mining and data science, and I'm sure it will be very interesting to hear about this new field that is growing on the data science and on data mining. Thank you.
Thank you, Rita. I would like to first thank the invitation for Boris, and also the committee member Tima and Pascal. I met Pascal last year in India. So I'm so happy to be here. I don't think I can be better than the sun performers, but I will try. Okay. So this is my talk. So as Rita said, I was sent by Chinese government to USA 1985 for my PhD. After I got my mathematical department, degree from China, and also MBA degree from China. So I was the first group of people who got MBA degree. So then, I went to USA because I just thought I will be there for 3 or 4 years for my doctoral degree. Eventually, so I will stay there for 20 years. So, and in the year 2004, Chinese Academy of Sciences invited me back to China. So I decided to relocate myself. So I still keep my professorship in USA, but basically on leave from here. So that's what I'm doing. So first, when I went back to China, so we built a research center for data science. And the center was originally built up in the year 2007. It was now become the first group of such a center in the world. So our center is 5 years older than Columbia University. So they built the research center in data science year 2012. And this year we built another research lab. It's called Big Data Mining and Knowledge Management. So that's the first lab, the national lab built by National Academy of Sciences. So, and I'm going to report to you what we have done for the last, let's see, 15 years, something like that. So my background was doing fuzzy logic first when I was very young. So I published my first paper when I was 24 years old, in 1981, so in China. So then, after some 30 years, so people recognize me for the George Cantor Award, So now, before I do that, and you see that 3 years ago, this tragedy has happened. So actually, John Nash has been my friend, not a very close and personal friend, but we have been, doing the conference for several times. This is the photo I took with him and his wife, Alicia, on the day of October 31, year 2011 in Hong Kong. So we have a very small group of people to talk about how the game theory can be used for internet business. So he was so excited. I remember, when we have a discussion, I told him, I said, if you look at the game, if you have 100 people versus 100 people, there's no way to find the Nash equation, right? What do you need to do now? Because you can find the interest, targets around those 100 people on one side of players to use data mining to find out their common interest. Okay? Then you can shrink them into 5 clusters, for example. Okay? you shrink the game into 5 versus another 5, so equilibrium can be reached. Or you can use a computational way to find out how convergence will happen. He completed the equation. But unfortunately, 3 days ago, when he picked up the famous prize, is for Amber Prize from Norway. So, and the car accident happened. I didn't know that, so we have to be lucky for this. Because I think, wow, none of us, when we ride the taxi, we have the safety belt. That's how we can do it. So this is a service warning for us. So anyway, sorry to miss it. Now this is my talk. So I'm going to talk about several ideas. The first one is to use optimization in data mining. I mean, you know that traditionally people doing data mining by statistics, by artificial intelligence. But very, very few people in 20 years ago doing by optimization because people knew every optimization problem related with NP hard. But however, since the computer has been very advanced, so we have no problem with NP hard. That's how the optimization becomes the central player. So if you look at what's going on, so the first area to use optimization in USA is credit card business. And this business is so big, it's about $200 billion every year. But Chinese, credit card business this year exceed US size. So because China has a very big population. So this is clear idea how to use data mining. So if you look at data mining, in year 2000, I wrote a small article for encyclopedia talk about what's data mining. So that's my point of view. I say that data mining is not just algorithm, it's a process. Okay? First, getting the data set, now we can talk about big data. So you are not going to use all the data which you have, but you have to use your time to see which particular data set you have to pick up the attributes from the available data. So the first one is the selection problem. So selection problem itself, basically, from our point of view, is a business problem. For example, you want to find out who are your best customers. It's called segmentation. This is not computer science, it's business. Okay? According to this, you can pick up some attributes from there. The second one is called, the second one is called the select, the transformation. So here, you can use the last method to massage the data, which we call the data pre-processing. Okay? We call the quick dirty methods. So lots of things to do. So this has nothing to do with the heavy mathematics. Very simple idea. So those two, the first one is important for the business people. Second one is for some data works. So basically, you need so many people to help you massage the data. The third one, you have to do the data mining. So basically, so here we are called, this is computer science. You usually can use algorithms to develop or use tools. Okay? So then the final stage is even more important. You have to interpret the situation of the results of data mining. None of us call the results of data mining is the knowledge. We call hidden value. How can you upgrade hidden value into the knowledge? Totally depends on the decision maker. Because the knowledge is for you, is knowledge, not for me. We are different. The knowledge for me today, but not for tomorrow. It's changeable. So that's the idea. So the last one is even more important. So if you say first one, last one, they are all the business problems. So computer science just plays a small part in data mining. Okay, that's the idea. So if you look at the methodology, I don't want to say because so many of you are working on DSS, right? You see those ideas. So however, if you see the central ideas over here is, so data mining basically, we have about 70% of the project related with classification, which is giving label. We know who you are good or bad, but now I'm going to produce the mathematical model to catch exactly what you want. This is difficult. So we have some kind of situation like type 1, type 2 errors, no matter what's going on. So we have to reduce those rate. So that's the idea. So according to those things, so we have something like similar time sequence. This is just like a behavior for you to use your credit card. This is like a springtime, summertime, and fall time. So people are changing the behaviors. That's a system going on. So now if you look at the mathematical tools, if you go back to 250 years, people start to use mathematical data analysis. So we have a situation like this. I remember about 10 years ago, a very famous company in US is called Gartner over the nation. So they have a report, the surveys to tell people what what is the best mathematical tools people have been using? There is no doubt. Number one winner is statistics. But do you know which one is number two? It's for sure. It is not, which we call the decision tree. I remember year 2007, I organized a conference for IEEE conference on data mining in Nebraska. So we gave a first award to Dr. Kunnan, who produced decision tree algorithm. We recognize decision tree as number one tools. But however, if you look at the influence of the people, so on mathematical tools, it's not this one. It's not one in mathematical models. So mathematical program. So if you look at all the 514 companies, every company uses mathematical models. Programs. For example, if you want to buy air ticket, okay, the booking system itself is integer form. So that's how. So I want to say that the optimization plays a major role. So this is a person I have been admired most. So actually, many of we know that who is Bayes, Thomas Bayes, right? But however, if we know the real history, Thomas Bayes was a person never published any paper about statistics. And it was Richard Price, his friend. So after Thomas Bayes' death, so he said, my friend talk about something like this. He put it in a publication. So finally, people realized this is Bayes' theory. Okay? But again, so it was Richard Price to introduce this to the world. But the formulation we use is called, prior probability. It's not from Price himself. It's from famous, French mathematician Laplace. So the theory of Bayesian theory should correct as what? As Bayes, Price, and the Laplace theory. That's the real case. So, however, maybe some of you know that. So he was very famous. He did, first, analysis in year 1978, public paper, by use, the text collections to produce what's going on with the British national paper. That's how, people in the field of statistics treat him as one of the fathers. Okay? Also, he was a great politician. He made a major contribution for the U.S. independence. So he taught, Thomas Jefferson and other people how to collect tax if they build a new nation in North Continental, USA. Okay? So after they built a new country, so he was invited to be the first secretary of treasury in USA, but he refused. So finally, Yale College, now the Yale University, gave him an honorary degree with George Washington, the father of the nation. So. And he was also famous for, women, movement. I don't know if you guys know that. We have lots of, female professors here, right? So you should pay respect to him. It's his theory to tell us men and women should be equal. Okay? But he couldn't make it in England. It happened in France. So, okay, this is a very famous guy, right? You can see, what is this? This is called multi-dimensional table. Okay? We have a rows of record, we have columns of variables. So basically, this is a situation which he did. He calculated the means and variance and like this, right? By hand. But now we use large scale computer to calculate millions of rows, hundreds of thousands of columns. Right? This is data mining. But however, if you look at each series over here, suppose your series each one over here is not a number, but by photos, image, by text. So now we are talking about big data. Okay? How can we process hundreds of thousands of pictures, hundreds of thousands of articles? So this is data mining. This is big data. So now big data didn't go anywhere. So now you can see that. So this idea, if you look at optimization, so object function can be mapped into the classification functions, and the contrast can be viewed as criteria. Then the solution criteria in single case, I'm talking linear programming, you are talking optimal solution. If you have multiple criteria, we talk about non-dominant solution. If you have multiple contrasts, we are talking about, we call it a potential solution. So all those things become classifiers. Okay? Then the structure itself becomes preference. But this is easy structure. So many situations you don't have, convexity, right? You have different concave. So again, so we can use optimization completely for data mining. All we are doing is we just not use optimization, look at how much calculation time we have, but we are doing it by separation of the data. That's the idea. So Now let's look at some examples I want to show you. So for example, this is simple situations. Now we have 2x2 case. So 2x2 case over here. So we can see that we have Tom, we have John. So those two people by their credit rating, which knows our credit rating. The first one is salary, age, and where do we live, all kinds of things. How many variables we have? 480 variables. Now we can just use 2. Okay? Now we will say who is good guy, bad guy. Suppose we use 10 as a boundary value, then we can find a solution 0.4, 0.6. So use 0.4 multiple 6, 0.6 multiple 8, we have a 7.2. And this guy, so John got an 10.4. Of course, John and Tom are separate. Very easy. But however, this situation is fake, right? Because we do not have we have perfect separation, which is alpha equals 0. Most likely, many data sets, they are overlapping. How can we put them away? That's the idea of data mining. So data mining itself basically is a separation of data. So now let's see this story. We don't have anyone from Korea, right? So I was in Korea last year for 2 years. So this is a Korea 38 parallel story. So you can see that. This is 38 parallel, right? This is North Korea, this is South Korea. I cannot say North Korea is really bad, I don't know. Bad group versus good group, right? A few days ago, there's international women delegations cross the border, right? So you can record that, right? Now, if this is 30 degree, if you go to there, you can see there's DMZ on both sides, 2 kilometers wide. I believe those women, they walk for 4 miles from this 4 kilometers, in that area. But however, if you look at this point, so this point over here he's supposed to be bad guy, but he is located over the border. So basically, we want to minimize this alpha so that we can pull him back. Same thing, we can maximize beta to say the distance. So we minimize maximum beta. What does that mean? Multiple criteria. Okay, so this is a very important idea. So we can use multiple criteria to pull them away. That's the idea. So now you see, if you have 3 groups, you just have 2 cuts. Theoretically, we can prove very easily. We have done that. So if you talk about n groups, you have n minus 1 cuts. The more cuts you have, the more complexity you are going to involve with bottom. That's the trade-off. Okay? So then we can do something like this. This is a paper we published in 2001. So when I was in USA, so we maximize the beta or minimize the alpha. So you can see that if you want to reach both conflict objectives, so this is the MC program. Okay? But certainly we can talk about lots of algorithms we produce now. Now, let's see. This is a classical examples which you could not use for his decision tree. So we have 14 people over here, age, income, student, credit rating, 1, 2, 3, 4. So 4 attributes. Compared with racial price problem, this is small table. Right? Now, this situation is real case like this. So we have 9 people is yes, has computer, other people have no computer. But no matter which algorithm you use, the training results will give you some type 1 and type 2 errors. So like this one, this guy has a computer, but we say no. So it looks like we treat the good guy as a bad guy. So it's type 2 error. But in statistics, type 2 error is difficult to be handled. I have a great teacher. His name is Glenn Schiffer, who did the theory on this. He was sitting on a computer when I was in USA. So now let's see that. So if we have this guy has no computer, we say that this guy has a computer. So this type 1 error. I always make a joke. The famous US actor, his name is O.J. Simpson. Right? O.J. Simpson is a classical example for me. So that's type 1 error. Okay? In 1996, people accused him killed his wife. But if the judge put him to the sentence, then there's an uprising in Los Angeles. So for political reasons, they didn't do that. Okay? He was a bad guy, treated as a good guy. Okay? So after many years, about 7 years ago, he was caught in Las Vegas. He robbed a jewelry store. He was put in sentence now, 49 or 48 years sentence. I guess he is going to enjoy his life, the rest of life in the jail. Right? So finally he was caught, which means type 1 error always can be corrected. Right? So but anyway, so in data mining, we don't mind about this. Type 1 makes sense, type 2 error makes sense too. For example, if we say we treat the bad as good, So whenever I give you credit card, approve credit card, I will assume all of you are good guy. Which means that I will treat bad guy as a good guy. Is that clear? Right? So inversely, if you have a credit card from my bank, I will treat all of you as a bad guy. Which means that I treat lots of good people as bad guy. Right? So it's good for me. So you can see that that's different from data mining. Now, second idea is called intelligent knowledge. This is my contribution when we went back to China. So, as I told you, when we did the data mining, we never see the hidden pattern is knowledge. How hidden pattern can be upgraded into knowledge totally depends on decision maker. That's how DSS comes from. Right? So we have to see how this decision maker to look at the results of data mining to see if it's useful or not. So, which we see this kind of importance from the consulting business. There was a very famous Chinese company, Austria IPO is called Lake Easy. So they asked me to do some research. They have three businesses at that time. The first one is game. And you know that you never can do game by data mining. Even you have so many people play your internet game. But game normally you do not expose the identity of people. For example, if you play a game with someone from Brazil, so that person says, okay, I'm 80 years old. Her, you thought maybe I can date with her. So when you see her at the airport, you will say, my gosh, this is 90 years old lady. Right? Because that's how anywhere a game cannot be sold. So that's not data mining. Doesn't make sense. Second one is advertisement. There are so many people doing advertisement on their internet. But however, the CEO knew there are only few people, few big players giving money. Others, no money. Right? So that's not. But however, VIP service is data mining. So there are so many people joining the VIP, mailbox service. So after a few days, they are leaving. They don't know why the people migrate. So that's data mining. So we found that we use, they say, okay, Dr. Xi, your algorithm is good, but however, it's difficult for our people to operate. Why don't you use the easy one? So we use the Kuhn's model, decision tree. So 4.5. So we use that model. We still have the results from 1,000 rules to find 245. I say, my gosh, this results of data mining 245. That's number one algorithm. So I don't know what's going on. I gave this to the marketing manager. So she was, when she said it, she's so happy. She said, my gosh, you find it. I said, how? I didn't know. So she said, you see, your number one rule, number 4, number 6, number 7, this is exactly what I'm looking for. You find it. All others garbage. So I said, my gosh, this is important research program, right? If I'm you, if I classify your ideas, your concepts into the results of data mining to first screen, then we got intelligent knowledge. So finally, Chinese government gave us big award, gave us $7 million award, so to do this research. So we did that. So now, what do we say? We said, okay, so the data mining results can be regarded as the first order of knowledge mining. The results of data mining is called, hidden pattern. We can view hidden pattern is rough knowledge, right? So rough knowledge has to be considered as a decision maker, as a second order. So then we can study intelligent knowledge. So you see, this makes lots of sense, okay? So we just probably work on this. Now, if we go back to knowledge management in business area, so many people doing this. Like my big brother, basically who graduated from my advisor, Milan Zanini. So he did lots of knowledge stuff. So we can classify knowledge in different ways. So now we can see that the first one is if we see we treat the data into the knowledge over here is called knowledge. This data mining we call the first order. The second order is different, right? So second order we can look at how those people like Lonaka, the creator of knowledge management, Milan Zanini, they classify knowledge into several types, like specific knowledge, empirical knowledge, okay? So common sense, all those things together. So you have a classification of knowledge. Okay? Now, depends on how do you classify decision makers' knowledge into the results of data mining. So this is the idea we need. So we can put the mathematical form like this. If this is a rough knowledge, we have a union of part of gaining decision maker knowledge. You can say this knowledge is from the power set of the value. Okay, that's for sure. So now, if you look at properties, so the mathematical property is very easy. If you find the results of data mining is what you need, you are done. Otherwise, more needs. Right? linear situation. If you got more, so you can see that. So you can, if you have this, so you just subtract. If you have more, you can take them out. So otherwise you have a decomposition. So basically you can start in mathematical field. Okay. So now furthermore, so you can look at the knowledge go up into the intelligent strategy. So finally you come up with something like this form. So I will speed up a little bit. So this is decision making. So we can see now data mining is just first order. Graph knowledge plus human knowledge is type 2, so it's T2, intelligent knowledge. Then we have strategy, go here, we have wisdom from learning process. And we have actionable knowledge from people. I remember when Nodaka talked with me from Japan, he said that, he said, this makes lots of sense. He said that, during Second World War, when Japan invaded China, so finally he said, history tells us, the small country cannot invade a big country. Same thing, Hitler cannot conquer Russia. It's impossible. So they are wrong in the first place. Okay? So that's about why? Because once the situation in China has, we are going to slow down. Japan has small population, right? You cannot occupy the whole country. Eventually you will be back. Right? So I just sorry, this is my personal idea. If Japan did if the Second World War did over, maybe Japan is part of China now. You know why? Because by election Japan has small population, right? You have to elect people to elect. So Japan is part of China. So you can see, so that's the history. Anyway, so now the big data. So what is big data? I don't know how many of you see this photo. This is a very famous photo. I like this photo. Actually, the guy who drew this picture didn't know anything about big data. But he already showed us about 3 different meanings of big data. Number 1, so he said I use Amazon.com database, Twitter score, internet, and location history, government data to calculate you data from different sources. Right? Second, data has to do data mining. So I use data mining to find out your rate of welcome is 23.5. So you are not welcome. So low, right? Number 3, he's supposed to report his boss, but he made decision immediately treat himself as the final decision maker. Say, okay, I'm sorry, you have to get out. Right? What does it mean? So the big data mining changes the strategy, the structure of our decision making. Okay, so that's the idea. So now those stories, we know lots of things right like this. So again, you can see, everything related to big data is a phenomenon, environment, body world, important things, body world, right? Because we are talking about data mining, knowledge mining, talk about lots of stories like BIBA. Now we think big data is better than big, mean lots of things, right? So it's a big challenge too. So we have friends say, okay, data mining, the big data is good. When big data is coming, the people who like us doing data analysis has no problem for research fund for your entire life. Because people have to use data. Right? So which is true. So now this is the idea of big data. You say it's so big, it's still growing. Okay? That's NSF definition. And we did several meetings in China. This is the way we come up. You can see that. So we say big data is complexity, diversity, heterogeneity, and high potential value, which, this is important, are difficult to process and analyze in reasonable time. If you can do it in short time, we don't have any problem. Okay? And you want to make politicians to know what's big data. Because Obama did the government plan for the USA, right? Chinese leader didn't do it because Chinese leader is a leader like this. They are all graduate from engineering background. They have to know what big data is. Too difficult to teach them. So finally, we gave them this definition to say that the big data is a new type of strategic resource in digital era, and the key factor to drive innovation, which China is doing, which is changing the way of human beings current production and living. It's not all this is important. Right? So we have to encourage innovation. So this is the 4 ways. So anyway, this is very important. I just showed you. For last 200 years, we think about traditional data analysis is by statistics. So this is descriptive idea. Okay? Then for last 50 years, we are talking about artificial intelligence. We say, okay, there's learning process. But now, all those things are based on the digital data. How do we do non-digital, non-digital? Okay, we call it non-structured data, right? This is difficult. So, what do we need? So now, I don't know how many of you see this book. So there's a very famous book about big data by those two authors. So, but however, they have misleading point for us. So this is when big data is coming, you can analyze everything. We as scientists disagree. If you analyze everything doesn't make sense, how can you do prediction? Right? When big data is big, that means your sample is big. If the sample is bigger, so the solution could be robust. Right? So that's not right. Second, he said, okay, we just do the rough solution, not precise. That's not true. So I told my story, I said that, the psychologists study showed that the strong person, like a Schwarzenegger, right? Arnold Schwarzenegger, right? If we put him in the desert, doesn't eat anything, no drink, for 3 days, he's going to die very quickly. Okay? So he lost the water, right? If we put a woman there, the women will last longer than man, right? Because of digesting process. But before his death, we gave him a rough solution. Is what? Is ample. Then we gave him precise solution. Is a beautiful photo of a girl. Which one he wants? But of course, Schwarzenegger will say, okay, I like ample. Why? Because without ample, he can survive. He cannot survive, right? So after 2 bites of ample, he will say, I need this photo too. That's human nature, right? So we have to find a rough solution, then precise solution. That's for sure. Then finally, so reasoning is very important. So those things are very important. So this so many things for the big data research. So we don't want to mention for details. But what's data science? The data science is a science for data collection, management, transformation, analysis, and application, in which the key is discover knowledge from data. This is our terminology. This is still rough, so we are still working on this. So now, let's see. For data science, we have lots of research going on too. So last year we published a paper. So I edited a special issue for the U.S. official magazine. It's called The Bridge, so which is a National Academy of Engineering. Right? So it's called what? It's called the Global View of Big Data Challenges. We have so many people publishing over here. So you can see the paper from USA, from China, from Japan, from European Union, from Commonwealth countries, and also from Latin America. So in this paper, I listed the challenges. Challenge 1: how can we transfer non-structured data into structured format? Then we can use available data mining tools. That's number 1 challenge. Okay? So, challenge 2. So, big data pushes the change of management science from traditional data mining, we call them model driving and case driving into the data driving. This is important. Whenever we see something, we have to consider data. Okay? So, this is a state of mind of change. So, number 3 is called, in data situation, we have structured data, semi-structured data, and non-structured data. In decision making, we have the same thing, right? So structured decision is for the ordinary people, then for manager, same structure. For the high-level people like Warren Buffett, he just say yes or no, that's structure. Right? How those two structures related? That's the photo first time I see that. Okay, this guy said, you're not work hard. He become a final decision maker. Right? Between the data structure and decision structure, we have something called knowledge structure. What's going on? This is challenging, especially for our group here. So, but no matter what's going on, so we can see that we have to treat the big data into small data, so that we have a country the knowledge, right? That's what data mining to do. Having information into thin information, rough knowledge into precise knowledge. That's the general ideas. That's the people need. Okay. So let me show you a few, let's say cases which we have done. We have done lots of things. I just show very quickly 5 minutes. Finish this talk. So this is the case study which we did, in USA. So basically, I did it for the very big companies for First Data Corporation. So this company runs the data not only for USA but also for Germany, for part of France, for whole entire society of England. So many countries. So And you see, this is the ideas we do. So basically, the idea is very simple. We just look at the accumulated distribution versus the good and bad. So, cases. Okay? So, then this is the case score in the situation. So we have the US, score over here, and basically this is all from the FICO companies, and with our score. So quickly I will show that this is two group analysis. This is called cutting, blacklist, right? Try to separate people as good and bad. That's blacklist. So you can see that's the real situation. This is for cumulative, bad versus good. So then you can see there's 2,000 cases, 6,000 cases. And we have 3 groups as well. We have good, bad, ugly, right? So this is training, and we have learning. So learning this data is real data from Chase Bank of USA in Manhattan. Okay? So and this is there are 4 groups. So finally we have 5 groups. I just want to show you the idea of 5 groups. You see, this group is the people have a bankruptcy with charge-off. That means you bankrupt, you have low wife, low house, nothing. Basically, society will give to insurance company, right? So case is closed. The second one is called, bankruptcy without charge off. You have a job, you can pay back little by little. The third one is delinquency. The first one current, the last one, people like Bar or Buffett, right? So basically, outstanding. This is exactly the idea. When you get your credit card report, you got a coupon from the major company. Okay? So they cannot give you coupon like air ticket free to students, right? Not service mistake. Okay? So that's why you go these kind of things. And we did this for Chinese, credit scoring as well. So, this is a major job I did for China. So basically, I went back to China year 2004. I did this for central bank for 3.5 years. Finally, we completed this process. So we use our mathematical model to calculate every score of Chinese 1.3 million. Okay? So, this is the invited talk which I gave when KDD has the first conference. This year, KDD will have a conference in Australia. So normally it's in USA. That's the #1 conference in data mining. So they invited me to give a lecture to talk about this kind of situations. So look at this. It's a technology here. Logistic regression. SVM. We call the supplemental machine, and our multiple quadrant decision making model. You can say genius score. This is so high. Our model is beautiful, very stable. So, and you see the score for 3 countries over here, right? This is Chinese score for 4 models. This is US score. So anything less than 620 is a subprime. That's how subprime prices come from. And Australian score is right here. So China's score is almost equal. Why? Because in China, people still pay big money to buy car, buy house. That's the people. Okay? So this is US distribution. You can see 50% of people are bad guys. This is the Pasang distribution, right? So, and this is Chinese distribution, almost equal. You can say actually all economy, most of the way like this as well. So, we have IMF, people give us very high, evaluations. So, and there are some famous guys, like a friend of mine, Philip Glover. So he said this is a very good results. So, but basically, not only for mathematician, I also did it for politician proposal to ask the Chinese government pass a law. Otherwise, if law is not there, they cannot do this. So that's the idea. So, wow, so anyway, then this is the famous World Market Corporation, the largest furniture market in USA. Do you know how big is the furniture market? The store they have? They have a new store opening in Dallas, Texas. The store has 500 car parking places. Okay? You go there just like Disney World. Kids have a place to play. You select your furnitures, just like shopping, entertainment place. You go back, they will shift the furniture to your home. Okay? So we did instant credit score for them. This is the US, credit bureaus. So that's our systems. And we did this system for them. Basically, so when you go there, we give you a credit card in 5 seconds, almost real time. When you fill out the forms, give to us, we scan to computer 1 second. So 2.5 seconds, our algorithm will select the people who, like you, 5 people, pop out to see which credit reading we should give. So quickly, no mistake at all. Okay? So this is a famous Australia company. We have someone from Australia, right? So, you know, BH #1 company in your country. I did I did this kind of data mining for them to look at the oils underground from the ocean. So, this is a basic idea, you know, from Australia, southern Australia, that's real, real. So, data, you see the data very complete. This is a 3-dimensional data. So, now, this is their case before, so this is engineering, MRI, so you can say this is a kind of sands over here, this is the wheel. If you see this oil, so we can predict 2 kilometers away there is oil. So you know what's the precise rate over here? So only 65% by MRI. You know, for MRI for our body, costs $1,000 US, right? To do one for your body. If you want to 2 meters square area, how much money you have to spend? Tons of money. Okay. Now, where do we place this by data mining? You see, this is our results of data mining. You see, this is pseudo wheel. The wheel doesn't exist. If I find oil over here, I will put the oil over here. You know what's the prediction over here? Okay? 45%. Remember, 45% will save lots of money. Okay? So this is a data mining can make sense. And this is easily I already told you, so I'm going to skip this one. Okay? So then this is insurance company. So the big insurance company just issue checks for the people who have claim, right? Now there's so many fraud for the people to do that. So we use this data mining to catch the bad guys, like bad doctors. So they produce a face report, a false report. So we catch a guy from Texas, Houston, Texas. We send him to jail. Even he's he's a famous doctor for 7 years. So you catch that guy very, very easy. Now, this is a company from my student. I have so many famous students in USA. I don't know if you know this company or not. You can Google it, right? Soji. Soji is a company. When we buy air ticket in USA, they have your information. Before your trip, they are going to give you online advertisement to show you what you need to do. Okay? For example, if you go to Los Angeles, they will tell you which car company you can get a rental car. They will process for you. If you go to New York, they will tell you which show you should go and Broadway. Okay? So let me do this for them. So this is so difficult, as I told you. So online advertisement. So only for the process transfer their data into the data which they can analyze, we took 14 months to do this. Lots of time. Okay, so I'm not going to say the details. You see this cookie, that's a deliverable product. What do we do with deliverable product? So we do not do just simple research with them. We have sent people on site work with them. Okay? So now this social media systems we did for Chinese government. Very fantastic. So because Chinese social media has been booming, so people excuse the local government officers to say they are banned and things like that, right? So now the central government wants to find out how people's view compared with real situation. So we did this. So you see, just give you 2 cases. This is called Smart Castle. This guy is a high officer to control highways. So when the car accident happened, he was there. Then people found out, oh, this guy in different places has his photo. Every time he has different watch. You see, different Swiss watch. How come this guy has so many watches? Right? You say, like me, I have $100 watch. Right? So finally they found he was copying. He was in jail for 7 years. Now, this is a good way. Oh, what about those things? Oh, they say beautiful women become mayor of the city. Beauty mayors. If they are some sort of lovers of someone, how come they become mayors in such a young age, right? So, but in fact, many of them are good guys, not bad guys. So that's the reason. So this system. So basically, so you can see that this kind of is somehow similar to slogan stuff, right? Because we have watched them, they give us back data to see what's going on. So we put them into the files to see if they are right or wrong, right? Into the documentation, So it makes lots of things. So internet business is booming in China. I have a friend of mine who was a professor at Texas Austin. He quit his professorship, went to Amazon.com first as a CTO, then Dell Computer as an Asia person. Finally, he got a venture capital. He asked me, what do we need to do? I said, okay, when did you use your experience from the supply chain in Amazon? Then, marketing from there, sell products to the people, the food. He opened his store. So, become the number 3 business. So we did a value and credit score for the customer for them. If we found that you have a fancy car, within 3 months, milk free, no charge. Eventually you will buy stuff from us, right? So all those kinds of things. And also there are so many people open store in their business. So we want to see if their credit is okay. So, and now the internet business is booming in China. Last year, Chinese GDP, 7.5 GDP, has 14% contributed by internet business, especially Alibaba. Okay, so this is great ideas. So this is also from my colleague. So who did this, website in the world? This number 1 is called 3 Health App. What does that mean? You look at a doctor, not to hospital, but with your cell phone. So they have about 50 million people to use their app. They have about 100,000 doctors. So now we are going to use data mining to evaluate how good the doctors are. So all kinds of things. So these are projects. So now in USA, Australia, in China, so it's a lot. So now where's data mining? Data mining is just beginning. That's social media. We are right here. Social analytics for data mining. So we need 2 or 3 years. For data science, we need more than 5 years. For big data analytics, it takes a long time. Okay, so I'm done. So basically, so I just want to say that. So this is our journal. So I have some handouts over here. If you guys want it, so over here. So I have 2 journals. One is called IDDM. So this journal has been last year our impact factor is 1.89. So it's ranked 12 in management science. Number 22 in computer science. So there's 130 journals. This is a new journal called Data Science by Ribeiro. So this is my new book, Intelligent Knowledge, just published right now. That's Ribeiro. So we have a conference over here. So hopefully I'm so happy that you guys have come here. Maybe sometimes we can do conference together. Yeah, I give you a proposal. So this year our conference is in Brazil. We have 250 papers. Okay. So maybe next year we are going to Korea. Maybe the year after next year we can find some place. Join the conference, right? Data science conference in Sydney, associated with PDD. So this is our another conference, 2 conferences. So thank you so much. Yeah. I will give those things to downstairs people. They can. If there's information, I can answer one.
That's what I was going to say. Are there any questions, for Professor Xi after this interesting, presentation and all the applications that big data can provide, nowadays, and the relation with decision support systems?
Yoshi, first of all, I want to thank you very much for all your practical views of your work in research on big data and data mining. It was excellent to see how far back you went to the 70,
80 years.
and then speaking about price and all these insights for developing technology these days. Great. And my personal and I think our view of the challenges and the danger in the data mining and big data these days is the data-oriented way to work for implementing solutions. And my questions to you now, they go in this direction. How do you see the compromise between accepting a solution data-oriented with, you mentioned that we have to process the intelligent part of the knowledge, but how do you see that the thing is happening now? Isn't it too much data-oriented and lacking the importance on the intelligence part of this solution?
You are talking about
decision support can help.
Okay. So basically, there's some different views between the DSS and the data mining. We know those things, right? It has been argued for business ability. Actually, 3 years ago, there was a paper published in MSQ, MS Quarterly. So they review the BI and BA stories. So by accident, they ranked me as number 3 in the world. It's awesome. But results of data mining cannot replace by machine, but people have to do it. So in this case, DSS for the human interventions should be an important factor over there. If you go to industry, that's always like that. So all that we can do as a researcher, we just find out the technical solution for that. But it's up to them. So this is the key ideas. So I summarize your ideas. So yes, 90% of them cannot be used for drop away from the analytical process, but you have to be combined with the human knowledge.
I also have a question. You know, in terms of, because the data-driven, sometimes the solutions that you give for the clusters, etc., the correlations can be wrong in the sense that sometimes it's because of a fact or something, and there is hidden knowledge that you are not extracting directly. You know, what is your view in terms of this, how to handle this kind of like hidden knowledge that it is still inside the clusters? Because if you do a solution and you say, okay, I have these 5 clusters, but who knows if you change some stuff or if you take one variable or whatever, how much it changes, you know, how is the robustness in this type of work?
Yeah. Thank you so much. You know, in data mining, so we have something called cross validation. That's a heavy process. So if you see the cluster, suppose you know this data, you have to use the algorithm to classify it into 5 groups, right? Maybe some 5 groups are not enough. You know, people are looking for something more to see the boundary between group 1 and group 2. So you have to put more, you know, variables, more, you know, human, or you know, we can transfer people's mind into some, you know, let's say contracts as added value over there to screen what's going on between group 1 and group 2 or class of group 2. So in that way, so you can see the details. But you know, man-machine interaction works.
Yeah, that's why again, decision support will help on this task.
That's true. I told decision support too.
Yeah.
So we have to class. So basically, they do not look at the detail of analytical process. They look at let's say strategic views, how people handle those things.
Any more questions? Anybody?
Can I ask one?
Yeah,
Of
please.
course.
Your challenge number 2 you presented, you said from model driven to
Model
data
driven,
decision making.
case study to data driven.
Because my understanding, for example, your pattern, it was presented from data to work knowledge to the age,
Action.
the precise knowledge that can be actionable. So if data is the original source for developing all the knowledge, that means data is the starting point. So should data-driven decision maker and model-driven decision maker be parallel, or should, as you presented, from model-driven to data-driven?
Thank you so much. So my idea is that even in the past we use model driving, you know, we use case driving. Doesn't mean those 2 drivings are not important. What I should say that is the basic driving should from data. That's the idea. So through the data in the process for you to identify solutions, of course you can use a case. If you don't have a case, how people know the implications, right? Because for people who are analyze data, they may not know the ideas, the things beyond the data. So those things become, you know, experience from the people. So you have to use their case to make your data driving stronger. So my answer is both model driving and case driving can be play important role, but data driving should be fundamental. Okay, thank you.
Any more questions? Well, if there is no questions, we want to say.
Yeah, we can interrupt.
This is a little present for you.
Okay, thank you.
Thank you very much for
We can enjoy it live. Thank you so much.
Thank you very much.